Welcome to myprojectbazaar.com. Now we are going to discuss about the product medical image denoising using rotated wavelet filter and bilateral filtering. Now we are going to discuss about the abstract for the process. In this paper we proposes an adaptive image denoising method, that is the algorithm, using a targeted external database images for a generic database. Here the targeted database references to a database that contains image relevant to the noisy image only. As will be illustrated in later parts in this paper, targeted external databases could be obtained in many practical scenarios such as text image like newspapers and documents. Here we use the medical images for the image denoising process. Other possible scenarios includes the image of license plates, medical images such as CT and MRI images, and the images of landmarks. Here we choose the CT and MRI images for the medical image denoising process. Hence the main objective of this taken CT images and the MRI images is to denoise the medical purpose, to refine the images and to enhance the medical images. Now we are going to discuss about the flow diagram for the process. At first the input image is taken from the database. The database is the folder which consists of the several input images. After getting the input image from the dataset, the pre-processing is carried out. In the pre-processing steps, we have to initially adding and removing the noise from the image. At first the salt and pepper noise is addition to the input MRI image, and then the initial noise removal filtering is applied to remove the noise. Then the PSNR and MSE is calculated for the initial noise addition and removal. Then the channel separation is carried out. In the channel separation, we have to separate the input image into three categories, that is the 3-band image, red, green, blue separately. After separating the channels from the image, we have to addition the noise for the each and every channels. If I give the input as 1 means the salt and pepper noise is adding, otherwise the Gaussian noise or speckle noise is adding according to the option. After the addition of the noise, the patch-wise selection is carried out. In this patch-wise selection, we have to segregate the image into 4 patches. After the patch-wise selection, the channels are concatenated and the noise removal is carried out. After the noise removal, the noise-free images comes out from the noise removal step by using the rotated wavelet filtering. Then the estimations is carried out. In this estimation part, we have to calculate the 2 type of estimations. The first one is the PSNR and the second one is the MSE. The PSNR is abbreviated as an peak signal to noise ratio, and then the MSE is abbreviated to mean square error. In this we have to consider the 3 type of PSNR estimation and the 3 type of MSE estimation. The first one is the input versus the existing noise, then the existing versus proposed noise, then the input versus proposed noise. So these are the 3 categories of noise removal estimations. Then these values are plotted and then shown in the graph. Now we discuss the initial running procedure for the process. At first open the MATLAB 2013 and change the current directory. If you want to execute the code means just right click in the main file 1.m and select the option run. Now you can see the folder dataset. In the dataset, select any one image from the dataset. After the selection, the process will be done automatically. Now this is the input image which I have selected. Then the figure 2 represent the noisy image. Figure 2 represent the noisy image. The noise which is added in the figure 2 is the salt and pepper noise. After the addition of the salt and pepper noise, the initial filtering is applied to filter the image, and the filtered image is shown in the figure 3. Now the figure 4 represents the red channel separation from the image. Then the figure 5 represents the green channel of the image, and then the sixth figure represents the blue channel of the image. After the channel separation, we have to once again enter the noise type. I have given the noise type as 1 and the noise range as the 0.1%. Then click the button OK. Now the noise is addition to the input image, and then the process will be done automatically for the noise removal. Now I will explain the process one by one. Now this is the noise addition image. Now the noise is addition to the red channel, and then the green channel, and then the blue channel. Now the blockwise separation is carried out. This is the result for the blockwise separation. Here the single image is converted into 4 blocks. Now the noise removal is applied. The noise removal is applied for the first of all in the red channel, then in the green channel, then in the blue channel. After applying the noise removal for the separate these 3 channels, the channel concatenation will be carried out and the final result will be displayed. Now this is the result for the original image, then the existing noise removed image, then the proposed noise removed image. The proposed noise removed image is the quality as it is in the input image. Now the time calculation for the overall process is shown in the figure 29, and the existing and proposed accuracy will be compared and then displayed in the figure 30. Thanks for watching this video.